Okay, you should have a copy of this where we're going to graph some information, make a scatter plot, talk about it. So this problem says, is there a correlation between test anxiety and exam score performance? Data on X equals score on a measure of test anxiety and Y equals exam score, consistent with summary quantities given in the paper, effects of humor on test anxiety and performance appears below. So we don't really know what study took place or what experiment they may have done. It obviously involved humor, and how that perhaps could help test anxiety. So what we're going to do is make a scatter plot of the data, and then we're going to comment on the form, direction, or form, strength, and direction, and then look to see if there appears to be any outliers. So let's talk about what that's going to look like. So you all should have this graph. So we're going to be putting the anxiety level on the x-axis. So remember, that means that's, if I could spell anxiety right here, that is going to make this, the explanatory variable is going to be our anxiety score. And then the exam score is going to go on the y-axis. So you're going to have to decide how to scale your graph. So in the x direction, I have to go from 0 to 23. And, I don't want to count by fives and make it all scrunched together. So maybe counting by twos along here. Okay. And then for the exam score, we have to go at least as high as 77. So, I could just about do by fives if I should have lowered this down one. But that's okay. I'll be up into my numbers, but that's okay. So I'm going to do that. So now I'm going to plot my points. So the first one is 2343. So I'm going to approximate where that would be. So I'm just going to suggest you just pause the video because I'm just going to plot all these points. And then you can just plot all the points too. Okay, so depending on your scale, it's going to make a difference. Don't forget I have a point up here at 0.77. So depending on your scale, you can end up making it kind of stretched out or more scrunched together. So you just kind of want to come up with something that gives you a good picture. So we're going to talk about direction, form, and strength. So hopefully you can see in the direction that we have a negative association. So I'm going to say negative association. As far as the form, I would say it appears, I can envision putting a line here. So I would say it's somewhat linear. And for strength, I'm actually going to call this moderate. Maybe even, I might even say moderately strong. I wouldn't want to say strong. I'm going to give you a different way shortly of how we can measure that, a numerical value we can get, and how we can talk about how strong that is. And any unusual points. Now, you might look at this 0.77 and think, well, it's not really unusual because it lines up with everything else. However, this is actually the point 0.77 is an influential observation. Notice that it's kind of it is kind of an outlier, especially in the x direction, and it kind of acts like a lever. If I were going to draw a line that would best describe my set of points, if I took this value out, the 0.77, my line is going to actually not be as steep. But with that point in, it's going to make my line steeper. So it actually is influential in describing my relationship and describing the strength of that relationship. It actually makes it stronger because it kind of pulls the line towards it. So it is an influential observation. Sometimes the values that are far away from the other data values in the x direction become more influential than, say, something that maybe was, if there was a point at 1635, probably not going to have as much of an effect on my numerical description to describe this relationship as this point over here does. So that would be direction, form, strength. And we should always provide it in context. So honestly, the best thing to do would be, and I'm just going to say this, not write it. There is a negative, linear, moderate association between anxiety level and exam scores. So putting the context into that as well. So I want you to grab your calculator, and we are going to enter some data into our calculator. So I'm going to go ahead and insert a name here. So if I go second and then insert the delete key, the INS, and I'm going to call this let's see, I'll call it, I'm going to lock my caps. If you hit it twice, it locks it. So oh no, that did not work. Okay, guess I have to hit it each time. Okay, so you can only do 5 letters. So this is going to be my anxiety. And then I'm going to call this one exam. And I suppose we could have just left it in L1 and L2, but we might, oops. Oh, that's no good. Hold on. Okay, I forgot to type second insert first. So now we're good. Okay, so in the anxiety, I'm going to list my data, the X values, and then I'm going to list the corresponding Y values in exam. I'm going to pause this. Okay, so once you have your data all entered, you're going to quit this screen. It will still be there. And now we want to make a plot. So I'm going to first go to Y equals, make sure I don't have anything there. If you do, you can delete it or deselect the equal sign. Now I'm going to go up to stat plot. So second and then the Y equals. And I'm going to turn plot 1 on. So the type of plot that I want to make is a scatter plot, which is this first one. And we're going to, our data is not in L1 and L2. So we have to tell the calculator where to find our data. So it's in a list. So if you go second and then hit the stat key to access the list, and you should have the ones we called anxiety. And then in L2, I'm going to go second list and go get exam. And the marking, however you want to do that. So I can quit that now. And I want to go ahead and take a look at my graph. So I want the calculator to select for me my scale. So if you go zoom and then number 9 is stat. So that is my data, and you can see the values. Now, a lot of times when I'm doing this, I don't like to have my X and Y axes on there because sometimes you can, miss the fact that there's a point right there. So if you go second format, you can actually turn your coordinates, your axes off. So if you turn the axes off, of course, you'll have to remember to turn them back on when you want them, but you just kind of get a really clear picture. Now you can still find, if you hit the trace key, it will still tell you those values. So the 2343 was the first one in my list. So it goes to that one first, and it's just going to kind of pop around to all of them. There's 1459, and then it blinks on it. So you can see what all the different values are if you wanted to see that. But you can see that I get that same graph. All right, so I'm going to quit this screen. Now, I told you that there's a way to measure strength numerically. So I'm going to show you how you get that value. So if you hit stat, calc, and we want to do linear regression. And I'm not going to tell you what all the things mean yet because it's kind of chapter 8. We're going to come back to this. But choose the one that's number 8, linear regression, and it says a plus bx. That's the one we're going to use. So I'm going to select that. Have to tell my calculator again, and you might be thinking, should have left it in L1 and L2, but we're going to come back and use this later. So if I do second list, and you can actually scroll up instead. There's anxiety, and do that over here for this. Ignore, oops, I don't know what I did right there. Okay, ignore the frequency list. We don't need to store it, and we want to calculate. All right, now you might look on there and say, okay, well, what does that mean? Well, if you get this screen, you might have a value for R. I want a value for R. So if you have one on there, that's great. If you don't, then you're going to do these steps that I'm going to show you right now. You're going to hit second, and then the 0 for catalog. Then you're going to select the D, the x to the minus 1 key, and you're going to scroll down till you get to what's called diagnostic on, and you're going to select that. And it says done. Okay, you only have to do this once unless your battery or calculator loses all of its power and you have to reset it. So now that I've done that, I'm done with that. So now I'm going to go back again and do this again. Stat calc number 8. Thank goodness it remembered my lists, and then calculate. And now it gives me these values. I have an R squared value and I have an R value. And the value that we want is this value that's called R. So R equals negative 0.7877. So this is called the correlation coefficient. And this tells you two things. It gives you the direction of your relationship, the negative. So that tells you we have a negative direction. And this is a numerical way that you can measure strength. And I'm going to show you with just a little number line. That is a horrible number line. That is much better. So I'm going to mark a 0 here and a 1.5, negative 1, and negative 0.5. So values of R are always between 1 and negative 1. So if you have a correlation that is equal to 1, that means your data is perfectly linear. Like if I took the equation y equals 2x plus 5 and made a table of values, it would be perfectly linear. So the correlation would be 1. If it was a negative association, it was perfectly linear, it would be negative 1. So all of our scatter plots, if they have a linear form, we can describe the correlation in between. You know, the closer it is to being perfectly linear, the closer it's going to be to 1 or negative 1. So we're going to describe, I'm actually going to mark 0.8 on here and negative 0.8 as well. So if we're between 0.8 and 1, we're going to call that strong. If we are between 0.5 and 0.8, we're going to call that moderate. So down here would be the same thing. So if it's negative, but still between those values, it's strong. And between these values, moderate. And then this direction in here is going to be weak. So that's just to kind of give you an idea. So we got negative 0.7877. So notice that when I went back, I talked about it and I said moderate, and then I changed it to moderately strong. So if I look at my little chart and I think about R is negative 0.7877, it's almost to the strong, but it's still in the moderate. That's why I say things like moderately strong. So if you're somewhere in the 0.7s, you can kind of just give it a better description. You can say, I I don't know, moderately weak kind of sounds like a strange thing to say, but you just want to kind of give a description. So this is just, not a hard and fast rule, but just to give you an idea of how you can describe correlation. All right, on page 152 in your textbook, there are some properties of correlation. Again, keep in mind that R is called the correlation coefficient. So that's what I'm talking about, that value. So the sign of the correlation coefficient gives the direction of the association. So I mentioned that. Correlation is always between -1 and 1, and I mentioned that. What I haven't mentioned yet, correlation treats X and Y symmetrical. And what that means is if you change the explanatory response relationship, so if I put exam scores as explanatory and the anxiety scores as response, then I would get the same value of R. So switching X and Y does not change the correlation. Correlation has no units. If the exam, if I were to change, well, correlation is sometimes given as a percentage. Don't generally do that. But there are no units to correlation. So you don't have anything, you wouldn't say the correlation is -0.5 inches. Okay, that would be incorrect. There are no units for correlation. So remember that. Correlation is not affected by changes in the center or scale of either variable. So if you change units, so if you change from, say, inches to feet, and you've changed your units, obviously your numbers are going to change, but your value of R is not going to change. Correlation, this is really important. Correlation measures the strength of a linear association between two variables. It's possible to have two variables be very strongly associated, but the correlation is small because it's not linear. For example, you could have a set of data, I don't know what this would be, but let's pretend like there is one. And you might have something that almost kind of creates a parabola pattern. That's an association, definitely an association. But if you were to calculate the value of R, you're going to get something that actually is very close to 0 if that were the case. So you have to look at the data when you are deciding if there's an association, because it's just not linear. There is an association, but it's not linear. So talking about the correlation coefficient isn't appropriate if it's not a linear relationship. And correlation is sensitive to outliers. If there is a formula for that, it might even be on your yellow sheet that talks about how to calculate the correlation. You won't have to actually do that. But it's sensitive to outliers. So when you have an outlier, that can really affect the correlation value. So I'm going to put a link to this game, Guessing Correlations. And what you have to do is you have to try and match the value of R, the correlation coefficient, to each graph. So if I'm doing this one, I notice that I have 2 negatives and 2 positives. And to me, clearly, this one looks like it's going to be closer to 1. So I think that's 0.87, which means this one would have to be the other positive one of 0.55. And when I compare these, one of them is a -0.47 and one of them is a -0.69. I think that this top one looks like a little more a stronger correlation. So I'm going to select that one, which means this one would be here. And then you can click on check answers, and I got them all right. Then what we could do is you can get new plots, and it will keep track of how many you get in a right before you miss it. So I don't know, maybe we should add a little incentive to this. I'll put something on Google Classroom, so because might come up with a little incentive to see how you do on that. But you can click new plots, and sometimes they're really hard, like these two right here. So let me do what I would do here. There's only one negative one if you look at the numbers, so it's got to be this one. This one is clearly the strongest, so that's going to have to be this one. So then I have these two options. It looks to me like the one on the bottom right is a little stronger, so I'm going to put 0.38, and I'm going to make this one 0.08. But I'm not I'm fairly confident. And those are right. But sometimes you get some that are just so close, and that's just the luck of the draw.